Hey everybody, this is Larry. This is day 12, wrong button, or old button, of the Leetcode Daily Challenge in December. Hit the like button, hit the subscribe button, join me on Discord, where we talk about all the problems and everyone share all their solutions and so forth. I mean, not everybody, but a lot of people do, so it's kind of fun. Today's problem is 416 partition equals subset sum. And before I get started on this problem, there are two things. One is there's a contest later today, so wish me good luck. But two is, so I get a couple of questions asking me about advent of code. It is December, and I actually do advent of code. So come, you could. I usually solve it at midnight or whenever it starts. So come to Twitch or come to Discord and just chat about it. Anyway, let's get started in today's problem. 416 partition equals subset sum. Okay, nums containing only positive integers, find if the weight can be partitioned into two subsets such that the sum of elements in both subsets is equal. Okay. So this is a very old school problem, very canonical, and the way that you can do that is actually what you would call the zero sum knapsack, something like that. I don't remember it off my head anymore, to be honest. It's been a while. So that's definitely a thing that you can do. And a couple of ways to do it. The way that I want to think about it is by actually, I'm going to try something new today. So this is like I said, this is I would say almost a textbook dynamic programming problem on a pseudo polynomial dynamic programming problem. And that is not to say that this is easy per se. It's just that this is really studied in if you take like algorithms courses or something like that. And I would also say that, to be honest, this is something that I want to play around with as well, is that the way that I solve this is actually not the way that many top people solve it these days. And some of that reason is because I started doing these problems in the early 2000s, like 20 years ago now, actually. What was it, 2022? Jeez. But so literally 20 years ago, and the TLDR there, the short story, is that back then, you just didn't really use sets. There's no sets. I was using C, not really a set. C++, people didn't really use STL. Maybe people did, but STL was considered not efficient, so people didn't really use STLs. Java did have hash tables, and I started using it from places, but some of the strategies are not quite the same, and I think those are. I mean, I did C# as well, but that's on competitive top coder, but that's a long time ago. But anyway, so my disclaimer a little bit is that I'm going to try to play around today and learn a little bit today, because the way that I usually write it is probably the way that maybe I was taught in textbooks, where you just basically have an array of 200 elements, and maybe they're force, right, times n, and then you kind of fill it out in that way, right? And that's fine. Or not, this is n, this is like max of nums times 100 or something like that, right? So yeah, so that's the pseudo polynomial solution. The way that I'm doing today is still gonna be pseudo polynomial, but I'm experimenting a little bit. So definitely fast forward or watch on 2x if you feel like it's a little bit awkward, because even though I know how to do it and I've solved it before, I'm trying to see if I could play around with a different way of writing it, right? And that's how you grow slowly. And maybe that's not for me, and then next time I stop doing it. But today you'll get to experiment with me. So hope this journey will be good. Okay, so basically I would have two sets, right? So for x in num, so we start off the set with 0, because that's just having no elements, and then now we would have something like current is equal to set, and then for y in previous, we do we add the number by itself, and then for y in previous current dot add x plus y, right? And then at the end we just see if and I said zero sum earlier, even though you're trying to get half. The canonical way of doing it is just to you do it for some elements such that you can get to the other half. Because then you have like another way of formulating it is partitioning into two different parts such that the difference is 0, right? I mean, it doesn't, yeah, it's not a big deal. But given the n is 0, 200 is fine. So we'll go over the analysis in a little bit. And I think this is roughly it. All you have to do now is just return sum of nums over 2, half in current. Except for this is not quite correct because the sum can be odd, right? So we just have to, how do I do it? Maybe I don't, okay. So, I mean, you could do floating math, but I always feel like that's a little bit awkward. Return false. And maybe we'll move this to the front so we don't do any of the work after that, right? And in here, and that should be good. Maybe, let's see. So I usually don't do it this way, so it is something that very easily could get wrong. So let's see. So we're all learning together, or you're watching me learn maybe. But why is that wrong? Oh, because I don't add. I forgot to add the existing numbers. Yeah, so actually, so then I just dropped the numbers. Is that right? Oh, I'm just being really silly, because then now he would just set this to this, right? Of course it's not going to be true if you don't progress. Okay, so this looks good. Like I said, as you can see, I'm a little bit rusty. I knew the concept, so I understand the concept of the invariant thing that I'm trying to do from the old dynamic programming. And this is dynamic programming, even though it might not look that way. And we're just trying to prove it right. And that's how I can, quote unquote, debug so quickly, because I knew what I wanted to do, even though I didn't notice because I was maybe rushing a little bit. Cool. Am I good? Yeah, let's give it a submit. Apparently I did it. Hopefully I don't get into issues this time. And apparently this time it even was faster and least memory. So, and since we did it last year, we can look at that solution real quick. But let's go over the analysis. So what is this analysis, right? Well, this thing is going to be O of n. And what is so I guess the tricky part is how does this thing fill out, right? And if you do it with dynamic programming, it's going to be more explicit. But here you can see that previous, this is a little bit hand wavy, but previous from the first loop is going to be at most one number. The second loop is going to be 2 number because you're doubling every time, so forth, right? So this is going to be technically 2 to the n, which is obviously not good. So then how is it fast enough if n is 200? Well, but this is, remember, this is a set. So we dedupe a lot. So there's also a cap on this, a secondary cap. So this is going to be max of 1. This is going to be max of 2 because you just have, whatever. But eventually it's going to get to the point where each number can only have 100, right? So that means that, roughly speaking, this is going to be at most 100 times n, right? Wait, sorry. 200 times n, sorry. The length is 200, and you have n. Each numbers can be at most, oh wait, no. I mixed myself up, sorry. So something like this, right? So that means that this, oops. In the last iteration, previous have at most 100 times 200 a number of elements, or 20,000. So roughly speaking, even though this isn't quite right, this is because this is just the last loop, right? But roughly speaking, this is, and you could sum it up in another way, but this is gonna have 200 times 100 with a low constant, because there's it's that divided by some triangle number-y thing, which is like over 6 or something big, right? So yeah, so that's the analysis. The reason why this is a little bit awkward, of course, is that it is what is known as pseudo-polynomial. Why is it called pseudo-polynomial? It's because there is a constant that is based off the number of bits that is to represent the number x, right? So with more bits, and if the size of the universe is big and if the size of the universe is small, it matters. So yeah, so this is basically how to do it. And I might have done similar problems in this similar way before, but to be honest, it's not something that comes innate to me. It's not something that comes often to me. I usually do it the other way. So yeah, let me know what you think, and let me know what you think about this explanation. But basically, or just discussion, I didn't really explain it, but basically the explanation behind this problem is that, you know, basically you look at one number at a time, and for every number, let's say we're at 11, we look at all possible sums from the previous numbers, and then we could either add the number, or sorry, we could either add the current number, or you don't add the current number. And then that basically is the 2 to the n thing, which is all possibilities, right? Because a number can either be in the final sum or not in the final sum, or in this case, in, let's say, the first half, so that the number you know, implicitly in the other half is the thing. Yeah, and there are also different ways of writing it, of course. Instead of just adding and not adding and then choosing the half divided by 2, you can also choose something like either either is this plus x or this minus x, and then now you can, I think this works, maybe not, I don't know, let's at least run it for the example, something like that. I think my base case has to be a little bit different, to be honest, because then now, because I think this is actually wrong, but it's just good for this case. But now actually maybe I don't need this, or maybe the reason why this is still right actually is because we don't need this, but 0 is always part of the answer. But then this is a little bit awkward. Oh, no. 0 is the initial answer. It's not always part of the answer. So, so this works. Yeah, that's why. I think this is good as well. So this is maybe another way of writing it, but it's the same idea of for every number is either on the left half or the second half. So the visualization will change how you write the code. This is basically, okay, if I'm adding it, I'm subtracting it from the sum because it's on the other half. And then the other one is just, okay, what is the answer for if I have 1/2? And actually, in this case, I don't need this either because 0's in the original thing. So, so this will always get added anyway. But yeah, so this is basically, okay, what numbers are possible on the first half, and then yeah, so there's different ways of writing it, and they're both equivalent. You just have to kind of figure it out. Okay. That's all I have for this one, for this submission. Let's take a look to see what I did last year. If I have to guess, is something like, oh, I did it, okay, so actually I did it tops down with the, I think this is the memory limited one, which I can see it because I did it kind of very, you know, the numbers are really big, right? Or there's a lot more constants on the stack cost and stuff like that, so I could see that. And then the other one I just converted to DP, and this is way more canonical. And of course, I probably said that here too. But of course, you actually don't need n times whatever space. You actually only need, you know, you only need the last element, right? Because so you can use the space optimization trick here as well to make the space much better. But I think I did it the other way just for illustration, so I probably don't feel that bad about it, because in my normally, I probably wouldn't do it if I was doing it in a competition or something like that. But yeah, but like I said, this is a very textbook-y problem, so I would rate this as very likely to be on an interview, or maybe not very likely to be on an interview, but I would not be surprised if this was on an interview just because it's so canon. So yeah, let me know what you think. You know, if you're doing contests later, have a good contest. I'll see you later. Stay good, stay healthy, to good mental health. Take care of yourself, and I'll see you later. Bye-bye.